Hello students, welcome to Shri Vardhaman Vidyalaya online education. Today we will see part 5 of chapter 13 magnetic effect and electric current. So in this part we will discuss the activity 13.8 and Fleming's right hand rules and electric generators and domestic electric circuits. So first we will see the activity 13.9. Take two different coil of a copper wire having a large number of the turns, say 50 and 100 turns respectively. Insert them over a non-conducting cylindrical roll. So that roll must be any in a thick paper roll. Okay. So you can see this one diagram. So this is in a thick paper roll. In this one, we are taking in a large number of that is in a coil of so many turns of 50 or 100 turns. Okay. So connect the coil 1 having a large number of the turns in series with a battery and a plug and a key. So first first coil will be connected to the battery and a key. Next the second coil also connect another with a galvanometer as shown in the figure. So you can see that one, this is a coil 1 and coil 2. So the coil 1 will be connected to the battery key and coil 2 will be connected to the galvanometer. Now plug the key, observe the galvanometer. If there is any deflections in its needle, you will observe that the needle of the galvanometer instantly jump to one side and just quickly return to the zero, indicating a momentary current in the coil 2. So when there is a current is flowing in this one coil 1. So when we plug in a key, what happens? The current will be flow in this coil. So the current will be flow in this coil. What happens? There will be the deflections in the galvanometer. So will be deflections. Why there will be the deflections in the galvanometer? Because of an induced current. Okay. So you can discuss what happens. So the disconnect the coil 1 from the battery, you will observe that the needle momentary moves but to the opposite side. It means now the current flow in the opposite directions in the coil 2. Okay, when we disconnect the coil 1 from the battery, now you can see that is a momentary move, needles will be most momentary, but in an opposite side, it means that now the current flows in the opposite directions in the coil 2. Now as we observe that as soon as the current in the coil 1 reach either in a steady value or zero, the galvanometer in the coil 2 shows no deflections. From these observations, we conclude that the potential difference is induced in the coil 2. So there will be the potential difference that will be induced in the coil 2 whenever the electric current through the coil 1 is changed. When the electric current in the coil is changed, either it will be stop or it will be start. Then the coil 1 is called as a primary coil and the coil 2 is called as a secondary coil. So as the current in the first coil changes, the magnetic field associated with it also change. So there is a magnet associated that it also will be what happens change. So thus the magnetic field lines around the secondary coil also change. Hence the change in the magnetic field lines associated with a secondary coil is the causes of induced electric current in it. So this process by changing the magnetic field in the conductor inducing a current in the another conductor is called electromagnetic inductions. So in practice we can induce a current in the coil either by moving it on a magnetic field or by changing the magnetic field around it. So it is a convenient in most situations to move the coil in the magnetic field. So in this one what happens? So the current in the induced in coil 2 when the current in the coil 1 is changed. So when the current in the coil change, what happens? There will be the current in the coil 2 will be induced. So that will be induced current will be deflected in a galvanometer. Okay, so this we are calling as an what? Electromagnetic induction. So Fleming right hand rule. Stretch the thumb, forefinger and the middle finger of the right hand so that they are perpendicular to each other as it will be shown in the figure. So this will be the right hand, thumb, forefinger and middle finger, they are mutually perpendicular to each other. So if the forefinger indicates the directions of magnetic field and thumb shows the directions of an motion of the conductor, and the middle finger will shows the directions of induced current. This simple rule is called as a Fleming right hand rule. So in the Fleming right hand rule, the thumb will shows a movement of a conductors, and the middle finger will shows a magnetic field, and this finger will shows a current induced in the conductors. Okay, so this we are calling as an what Fleming right hander rule. So that is once again the forefinger indicates the directions of magnetic field. So the forefinger will gives a directions of magnetic field, and thumb shows the directions of the motions, and middle finger shows an directions of an induced current. So this will shows an directions of induced current, this finger will shows an magnetic field, and this will shows an thumb. Okay, so this we are calling as an what Fleming right hand rule. Next, electric generator. So this is also a most important questions. So from this chapter, the two questions, one is an electric motor and another one is electric generator. Both are is very important questions. So electric generator is a machine for producing electric current or electricity. The electric generator converts the mechanical energy into electric energy, where it is an opposite that of electric motor. In electric motor, what happens, that is electric current is converted into mechanical energy. In electric generator, the mechanical energy is converted into electric energy. So a simple generator is called as a dynamo. For example, small generator used on bicycle for lighting purpose is called as a bicycle dynamo. So now we will see the principle of electric generator. The electric generator is an applications of electromagnetic inductions. Now we have seen the electromagnetic inductions. So the electric generators work on the principle that when a straight conductor is moved in a magnetic field, a current is induced in the conductor. So when a magnet means straight conductor is moved in a magnetic field, what happens? The current will be induced. We are not giving that current, so current will be induced. So that will be called as an what electromagnetic inductions. In electric generator, a rectangular coil is made to rotate rapidly in the magnetic field between the poles of horseshoe type of magnet. When the coil rotates, it cuts the magnetic field lines, due to which a current is produced in the coil. So due to the rotations of the coil, the magnetic field lines will be cut and a current will be produced. Okay, so the electric generators of two types, one is alternating current generator that we are calling as AC generator, and direct current generator that we are calling as a DC generator. So AC generator is also written as AC and DC is also written as DC generator. Now we will see the constructions and the working of this one. So the electric generator consisting of rotating rectangular coil ABCD placed between the two poles of permanent magnet. You can see the diagram, that is this is an ABCD, so it will be placed in between the permanent magnet. The two ends of the coils are connected to the two rings R1 and R2. So this end of the coils will be connected to the two rings, that is an R1 and R2. So these are the two rings R1 and R2. Okay. So these two rings, the inner side of the rings are made insulated. The two conducting stationary brushes B1 and B2 are kept pressed separately on the ring R1 and R2. So that is on a two brush that will be kept separately on a ring R1 and R2. So this is on a ring R1, here there will be the brush B1, and this is a ring R2, so here it will be in a brush B2. Okay, so this is an what we called as an construction of an electric generator. Next, the two rings R1 and R2 are internally attached to the axle. Okay, so this R1 and R2 will be attached to an axle. So there will be the attachment to an axles will be there. So R1 and R2, they will be attached to an axle, and this will be connected to an galvanometer. Now the axle may be mechanically rotated from outside to rotate the coil inside the magnet. Other end of the two brushes are connected to the galvanometer to show the flow of a current in the given external circuit. Okay, so now this will be connected to an axle and this will be connected to the galvanometer. So this is a construction of an electric generator. Now we will see the working. When the axle attached to the two rings is rotated such that the arm AB moves up and the arm moves CD moves downward in the magnetic field produced by the permanent magnet. So let us say that the coil ABCD rotate clockwise directions. Okay. So when the arm it will be coil will be rotated in a clockwise direction. By applying the Fleming's right hand rule, the induced current are set up in this arm along the directions AB and CD. Thus, the induced current flow in the direction of A, B, C, D. If there are the large number of the turns in the coil, the current generated in the each turns add up to the given large current through the coil. This means that the current in the external circuit flow from B2 to B1. Now see the first diagram. So in this diagram, you can see that is a rotation of a rectangular coil. It will be in a clockwise directions. So in the clockwise directions, you can say that is an AB will be moves in an upward directions. Okay. So when the AB will be moves in the upward directions, what happens? The CD will be moves in the downward directions. So the rotations of a coil will be in a clockwise directions. So in the clockwise directions, when it will be rotate, what happens? The current will be flow from a B to B1. Okay. Here you can see an easily. So that is an B2 will be connected to an split brush B2, R2 and R. Okay, now here R2 will be connected to B2 and R1 is connected to the B1. So when during a half rotations, what happens? So this when the rectangular coils will be moves in a clockwise directions, it will be moves, the current will be moves from a brush B2 to B1. So that you can see that the current in an external circuit is flow in an B2 to B1. So here it will be, it moves from an B2 to B1. Next, after and a half rotations, the arm CD started moving upward and the AB moves downward. As a result, the directions of the induced currents in the both arm change and gives rise to the net induced current in the directions DCBA. So the current in the external circuit now flow from B1 to B2. Okay, now so this is an during and a half rotations. Okay, next half rotations, what happens? That is an a CD will be moves in an upward directions and AB will be moves in a downward direction. So at that time, what happens? So the current will be flow from an a B1 to B2 and here it will be current flow from an a like this. So AB will be moves in the upward directions and again what happened? The current will be moves in CD, that C will be moves in downward. The current will be flow from B2 to B1. Next, during the second half rotations, that is the rotations of the coil will be in an anti-clockwise direction. So in the anti-clockwise directions, what happens? That is an CD will be moves in an upward directions and BA will be moves in the downward direction. So at that time, the current will be flow from DCBA, and in this one, the current will be flow from ABCD. Okay, so and here DC BA, so and the current will be flow from the split ring, that is B1 to B2. Okay, so this is that one, that is the extra current in the external circuit now flow from B1 to B2. So thus after every half rotations, the polarity of the current in the respectively arm change, and such a current which change the directions after equal interval of time, this is called alternating current. So that we are calling as an AC generator. To get a direct current, a split ring type commutative may be used. With this arrangement, one brush is at all time in contact with an arm moving up in the field, while the other is connected with an arm moving downward. So we have seen the working of the split ring commutative in the case of electric motor. So thus the unidirectional current is produced and this generator is called as an DC generator. The difference between the direct and alternating current is that direct current always flow in one direction, whereas the alternate current reverse its directions periodically. Most power stations constructed this day produce AC. In India, the AC changes directions after every 1 upon 100 seconds. That is, the frequency of AC is 50 Hz. An important advantage of AC over DC is that electric power can be transmitted over long distance without much loss of energy. Now you can see the difference of AC and DC current. AC, that is alternative current. The current in which the directions is changed periodically is called as alternative current. In India, most of the power station generates the alternative current. The directions of current changes after every 1 upon 1000 seconds in India. So frequency of AC in India is 50 Hz. So AC is transmitted up to long distance without much loss of energy is the advantage of AC over DC. So this is alternative current, okay, and this is a direct current. So the DC, that is a current that flows in one direction only, is called as a direct current. Electrochemical cells produce a direct current. So this is will flow in only one direction. So this will be flow in a change in periodically up and down, okay. Advantage of AC over DC. The cost of generator of AC is much less than that of AC. AC can be easily converted into DC. AC can be controlled by the use of torque, while involves less loss of power, where DC can be controlled using resistance, which involves high energy loss. AC can be transmitted over long distance without much loss of energy, and AC machines are short, durable, and do not need much maintenance. Disadvantage of AC. AC cannot be used for the electrolysis purpose or showing electromagnetism as it reverses polarity. AC is more dangerous than the DC 22. So this is a advantage and disadvantage of an AC and DC. Next, our topic is a domestic electric circuit. In our home, we receive a supply of electric power through a main supply, that's also called as main, either support through an overhead electric poles or by an underground cables. One of the wire in this supply, usually with a red insulator cover, is called as a live wire or positive, and another wire with a black insulator is called as a neutral wire or the negative. In our country, the potential difference between two is a 220 volts. So you can see the diagram. So in this diagram, so this one is a live wire, and black color is a neutral wire, and green will be that is an electric wire, okay. So that it will be given here. So the black insulator is called neutral, and that is one of that is a red insulator, that is we are calling as a live wire. This is a diagram of electric circuit. Now at the meter board in the house, this two wire passes into the electric meter through a main fuse. Through the main fuse, they are connected to the live wire in the house. This wire supplies electricity to the separate circuit within the room. Often two separate circuits are used, one of 15 ampere current rating for the appliance with a high power rating such as geyser, air cooler, etc. The other circuit is of a 5A current rating for bulbs, fan, etc. The earth wire, which has insulator of green color, is usually connected to the metal plate deep in the earth near the house. So this is used as a safety measures efficiently for those appliances that have a metallic body. For example, electric press, toaster, table fan, refrigerator, etc. So you can see this one. This is an earth wire, okay. So they will be given with a very high voltage. This is a live wire. So you can see this is an electric board fused. So the live wire, it will be goes to one. This is an electric meter, and from an electric meter it will be distributed to a box containing main switch and fuse of each circuit. Now from this it will be given to a different room, okay. So this will be the diagram of a domestic electric circuit. The metallic body is connected to the metal earth wire, which provides a low resistance connecting path for the current. Thus, it ensures that any leakage of the current to the metallic body of the appliance keep its potentials to that of earth and usually maybe get a serious electric shock, may not get any electric shock. In each separate circuit, different appliances can be connected across the live and neutral wire. Each appliance has a separate switch to on and off, so the flow of the current through it. In order that each appliance has an equal potential difference, they connected parallel to each other. So you know about an electric that it will be connected in series as well as in a parallel. Okay, so here that is an flow of in order each appliance has a potential difference equal, so they have been connected to a parallel to each other. Now is electric fuse. Electric fuse is an important component of all the domestic circuit. A fuse in a circuit prevent the damage to the appliance and the circuit due to overloading. So overloading can occur when the live wire and neutral wire come into a direct contact. So this occurs when the insulation of wire is damaged or there is a fault in appliance. In such situations, the current in the coil abruptly increased. So this is a short circuit. So the uses of an electric fuse prevent the electric circuit and the appliance from a possible damage by stopping the flow of an unduly high electric current. So the Joule's heating takes place in the fuse melt it to break the electric circuit. So using the Joule's law of heating, so that it will be take place in the fuse melt, it break to electric circuit. So overloading can also occur due to the accidental hike in the supply voltage. Sometimes the overloading is caused by the connecting too many appliances to the single socket. Okay, so this is about the electric circuit. Now you can see what is a short circuit. Short circuiting is caused by touching of live wire and neutral wire and suddenly a large current flows. This happens due to the damage of an PF insulations in power line, a fault in the electric appliance. Okay, so what is short circuit? Short circuit is nothing but when a neutral wire and a live wire will be touch each other or in a sudden large supply of a current. Then overloading of electric circuit. The overheating of electric wire in any circuit due to the flow of large current through it, it is called overloading of electric circuit. Suddenly a large amount of current flow through the wire which causes overheating of wire and may cause fire also. Next one is electric fuse. So it is a protecting device used for protecting the circuit from the short circuit and overloading. It is a pieces of thin wire of material having a low melting point and high resistance. A fuse is always connected to the live wire. Fuse is always connected in series to the electric circuit. Fuse is always connected to the beginning of the electric circuit. Fuse work on a heating effect. So this electric fuse having a low melting point and a high resistance. Now you can see this one. This is a fuse. So in the fuse there is a very thin wire. So it will be having a very thin wire of materials of having a low melting point and high resistance. Why it will be having a low melting point? So if it is a very high voltage will be supplied, what happens? The wire will be melt and it will be break. So at that time what happens? It will prevent a damage. So this will be the fuse. Now this is about an overloading happens. So what happens? That will causes a fire. So overloading of a large amount of current flows through the wire which cause overheating of the wire which causes an. So in a one plug there is so many plugs will be inserted, so there will be what happens? So many overloading means overheating will be happens. So due to this there will be fire will be happens. So this is about an domestic electric current electric circuit. So now listen students, in your book, so it is given that is on a page number 233, then 237 and 238. So that is given in a blue questions, so that you have to write in your notebook, and also in the page number 240 and 241 there is exercises given in this page, so you have to write this in your classwork notebook. So our chapter is finished in this one. So thank you.